Another example is the CP3 emulator, which can fully run scripts. And to look at how attacks are leveraged or how many attacks, different attacks leverage PowerShell or C script or JavaScript, we can emulate those scripts in a fully enclosed sandbox environment so that they even run in this sandbox environment so that we already know what behaviors they are going to take, and we can identify the suspicious behavior and block it beforehand or upfront. And again, on a different phase, the intrusion prevention helps in the exfiltration phase by monitoring outbound communications and to help in blocking any command and control traffic to prevent data exfiltration. So mainly all these technologies work together and share information from one layer to another, so they can make the intelligence and protection of the previous layer better. So it does not mean that if they are stacked in a static way that each one is just consolidated to the phase that it's working on, but rather, no, it's a complementary effort to bring all these endpoint protection features to work together and enrich each other and help in leveraging each other to get better protection and better detection capabilities across the attack chain. So this leads us to the fact that the focus is to catch the malicious activities as far to the left as possible. And it's important to note of that because we're trying to eliminate the possibility of the infiltration or the initial access or execution or persist during different various phases and keep ourselves in a more constructed way based on the attack surface reduction approach, which adaptive protection gives so much value to that, which we are going to talk more about, and then the detection and response as well. So all of these technologies and protection engines, all of them are backed up by the Global Intelligence Network. And this defense in-depth approach really helps in identifying threats earlier in the attack chain, and it helps in preventing attacks no matter how sophisticated these attacks are. So one of the important subjects is application behavior. We're talking here about well-known applications such as Office applications, Adobe Acrobat, or even Windows processes and tools such as WScript, CScript, or maybe certutle, which all fall under the umbrella of trusted applications. And the main issue here is that the trusted application behavior is different between customers. Each customer is unique and each exhibit different normal behaviors. So we have seen that the threat landscape has evolved to being more sophisticated, and the attackers no longer use general purpose attack tools, but rather they would develop attacks and or customize their attacks based on tools or applications that already exist in the environment. These are the living of the land type of attacks, which is mainly the misuse of trusted applications or dual use applications. Eventually, this way the attacker is evading the security measures since we are dealing with legitimate application behaviors that will not be easily detected. So hence a one-size-fits-all approach when providing protection for our customers is no longer sufficient, and we need to take more granular measures to cover these gaps. So dual usage tools can really be challenging and might lead to definite breaches in the environment, leaving an open door for an attacker to misuse a well-known application can be a huge risk. For some customers, downloading a file through PowerShell might be a usual and legit behavior. For others, it's something that is not normal, and leaving a door open is only increasing the risk of misusing such types of behaviors. The default explicit deny approach, which is maybe adopted by other vendors and competition, in the security area and the endpoint security area. The deny approach to all behaviors is something that's not productive. It's not a productive solution. It will only create more false positive detections, and it also creates more work to be done by the customer to eventually identify the blind spots and security gaps. And most importantly, it will cause interruptions to the normal end user activity and daily workflow. So if we look at the EDR approach, we can definitely monitor, we can definitely track all these types of application behaviors. However, the main issue is the amount of alerts and the different types of events that we need to ingest and investigate and look into to identify a real misuse of applications and accordingly start to take the actions one by one on them. So the most efficient way to deal with dual use tools is through adaptive protection. We conduct a monitoring phase, which helps us identify exactly what application behaviors are common and what applications are being used and by whom they are used as well. For example, it's very common that IT users execute command calls from PowerShell. This is as per their normal activity. So it's important to get such type of visibility when it comes to dual use tools. And once we have completed the monitoring phase and we are confident that all application behaviors have been profiled and we have a conclusion or a conclusive prevalence activity, which is a summary for what is mostly or commonly used in the environment, then we can safely close the doors and block them for all the unwanted or unused application behaviors. So we're reducing the attack surface and limiting the open doors that attackers might make use of to breach endpoints or conduct malicious activities. So we've blocked all the unused application behaviors, and for the remaining normal behaviors, we can further tune the adaptive protection policy and close the remaining gaps by only allowing the relevant users that require or conduct such type of execution. For example, only the IT users are allowed to launch the CMD through PowerShell. All other users are denied. And using this type of approach, we are reducing the attack surface to the bare minimum, and we're trying to leave very limited gaps for an attacker to make use of it. So to achieve a secure and productive application behavior control, we need to have a comprehensive and granular configuration options. If we look at other competitors, we see that as an example, Microsoft has only 16 generic behaviors that can be configured, each of which acts on multiple subsets and does not have a refined or granular configuration. So it's like either you block all Adobe Reader application behaviors or allow it to do whatever it wants. However, the adaptive protection policy provides a comprehensive and granular application behavior controls, which can close all the gaps without interfering with normal user activities, and it also overcomes the false positive detections. A quick look into the heat map of the adaptive protection. I'm going to shift to my demo. I'll be going back and forth between the slides and demos, but before we go to the Cloud Console to shift my lab environment, how adaptive protection mainly works is through ingesting global telemetry data to identify potentially risky behaviors of trusted applications. We have the customer telemetry data that comes from multiple control points, the real-time risk assessment, which is the monitoring phase and the monitoring of the application behaviors, conducted by the Symantec Endpoint Agent. The MITRE enrichment, so each and every application that is mapped to a specific behavior will have a specific relevant information related to the MITRE tactic or techniques that might be used to execute maybe malicious payloads or malicious scripts or whatever. So I'll just jump on to the Cloud Console. Let me just bring up my screen here and let's have a quick overview about the adaptive protection, have a simple test conducted, nothing complicated about it, but it just demonstrates how useful this and how comprehensive this tool is. So I believe you can see my screen clearly. I hope that the letters are visible and readable. I'll just connect to the endpoint and we look at one of the examples related to application dual use application usage. And I have here a simple Excel sheet which has two macro enabled buttons, one of them of which will call for a CMD for a command prompt and execute a directory listing for my local C or D drive. It's for the C drive. The execution passed through. We can see the listing of all the directories under the C drive, what are the files and folders. This is one behavior depicted by a well-known applications. How does adaptive protection sees it and what actions can we take and how does it prevent it as well? So if we go to the adaptive protection dashboard, the heat map is based on a monitoring phase. It is reported based on all the application prevalence. So whatever application behavior has been seen or detected by the endpoint, it is reported back to this heat map so that we can have visibility into what's happening. So the filtering can be done based on the zero prevalence, never happened, maybe a low percentage of this behavior has been seen, the medium, the high, and the ones that are still in the learning phase. So if we click on the high prevalence values, we can filter out all these high prevalence values. And we can look at the Excel behavior, which we just did a simple test on. So this is Microsoft Excel macros launching cmd.exe. We have a direct technique mapping. If we click on it, it will redirect us to the MITRE attack framework website so that we can have more information about this technique. How many devices this type of activity has been seen on? It's, in my case, it's 4 active devices, 100%. The policy tuning can be instantly applied from here. So we can either allow it or deny it from the adaptive protection heat map. If we click on the deny action and we go to review and apply the changes and save the policy, so the policy would be version 17. We can check it from my client, make sure that it takes the new updated version and check what does this result in. Okay, troubleshooting. Let's look at the policy version. It's already updated. We'll just go back to the Excel sheet and run the button again. However, this time it prevented the command from being executed. And if we go back to the dashboard to investigate, we will see an event that is triggered by adaptive protection, which refers to this type of behavior being blocked. So the main point here is to say that such type of application behaviors might be depicted and they might be misused. We can close them. However, we are not interfering with the overall functionality of the application. So we're not implementing a block on all Office-related process or child process communications or activities. It's a very specific and tailored behavior that we have configured. So moreover, on applying the block and deny list or block and allow list. So based on filtering, if we conduct filtering, we can action a bulk deny or allow on all these detected applications. And maybe the approach that is recommended and is mentioned as a best practice is to always look for the zero prevalence activities that are not detected in the environment. Now, unfortunately, my environment is still in the learning process. However, once it's done, you'll see a huge bunch of zero prevalence activities. And these are all reported back based on the common usage of application behavior. So whenever there is a zero prevalence activity, it means that this application behavior has never been triggered during the monitoring phase, and we can safely block this type of execution to limit the attack surface on it. And just a quick highlight on one of the new additions or new updates that was recently introduced to adaptive protection. And this is one important point because we're talking about adaptation and dynamic adaptation. Adaptive protection introduced an auto-tune option which schedules a task to zero preference behaviors, the ones that we were just talking about, to automatically deny all these zero prevalence behaviors and to limit and reduce the attack surface. And not only this, it dynamically adapts to whenever there is a behavior that is detected so that it can auto-configure or auto-tune the policy so that it can provide the best attack surface reduction across all the different well-known applications. The policy, just a quick skim through it. The policy can be applied to any specific set of devices or users based on custom requirements for maybe different departments or different requirements. You would see all the applications and the processes and Windows tools, each of which have under it the different behaviors that might be depicted. And we see the MITRE technique as well mapped for it so that we can have better understanding into how this behavior might be utilized in malicious activities, such as Adobe Acrobat creating portable executable files. This is a user execution type of technique. It could also be a deobfuscation or decode files or information. And the actions can be taken accordingly. So this is in general a quick look into the adaptive protection and highlight over the workflow of adaptive protection. So I'll just get back to the presentation slides to continue further on with the remaining slides, and we'll come back for a second demo, hopefully soon. Okay. So moving forward, EDR, another important feature, another important and key component. And from an architecture standpoint, the Symantec EDR is supported across all types of deployment models, whether it is on-prem, hybrid, or even on the cloud. For the on-prem model, EDR can be installed as a virtual appliance or a physical appliance. We simply integrate the EDR appliance with the on-prem set manager, which will in turn configure the EDR configuration or communication channel for all the endpoints, and also the sandboxing option, which is an important part of EDR. So the EDR appliance can be configured to submit files to either a local sandbox through the CAS malware analysis component for full on-prem sandboxing, or if not required, then the default action is to submit files to Cynic, which is the cloud-based sandboxing. And as for the cloud deployment model, it's all part of the backend. No appliance installation is required. It's just an EDR policy that needs to be enabled and applied to designated users or device groups. The core focus of EDR, of Symantec EDR, is to give you the visibility across the enterprise to detect hidden threats in the environment and provide a comprehensive forensic analysis of any malicious activity. It also offers the tools needed for threat hunting and investigation. We can investigate specific IOCs, for example, maybe by scanning endpoint machines and get a report of whether a suspicious file is stored on an endpoint. If a conviction or a search status is reported back that this file is found, then we can respond back and take the necessary action, maybe such as deleting the file. And on top of this, the rapid response, which is one important factor that helps to mitigate any suspected breach. We are aiming to provide a single click action that can take measures across the entire environment and limit any spread or further breach across the endpoints within the environment. This complete visibility, which is offered by EDR, is achieved by mainly correlating both the SEP prevent or the endpoint protection events and EDR recording events. The SEP prevent is all the events that are triggered by the endpoint protection technologies, such as the anti-malware engine or the sonar, which is the behavior monitoring, or even the intrusion prevention engine. On the other hand, we have the EDR's activity recorder, which streams events such as process launch activities, registry key changes, file create or file delete. It also includes network session events. So this is in overall provides a much more rich context and a clear history of any suspected or malicious incident. For example, if the anti-malware policy that is triggered maybe by a malicious activity and a file was detected and blocked, the Symantec EDR will correlate this triggered event with the relevant activity recorder events, which will result in a much more clearer pictures as to what different maybe types of process activity launch has been conducted or have occurred during the anti-malware detection, or even what files were created during the execution by this malicious file, or what registry changes or registry key modifications were conducted. Once data has been consumed by the EDR appliance, the data is then run through various analytics where incidents are created to help in guiding incident response team during their investigation. You have full visibility with MITRE ATT&CK, enrichment. All of the phases, as we've mentioned earlier, are mapped directly to the MITRE ATT&CK chain. We can have visibility into the tactics and techniques that were utilized during the incident. And the incident summary is, and all its accumulation of the events and all the triggered or parsed events are also compiled in a human readable way, such as Microsoft Office attempted to launch CertUtil or PowerShell downloading external content and executing it. So you won't need to decipher events and incident summaries. It's all displayed in easy and plain text. Core feature is one of the core features is the sandboxing. We can either configure manual or automatic sandbox submissions, and when the detonation is finished, the results are fed back into EDR for visibility, which also includes a conclusive conviction on the file, whether it is malicious or safe. And we can then accordingly take the necessary action against this file. Incident rules. These are behavior-based rules which are enabled, which can be enabled or disabled. Once enabled, an incident is created based on the specific rule from the suspicious or malicious activity. There is also the rule tracking that helps in identifying top activities or behaviors, which keeps you informed of the most prevalent behaviors that are occurring in the environment, the ones that are triggered most commonly and um, have a high risk. And recently, we have also introduced an option to configure custom incident rules. So you can build up complex incident rules that will be used to create events and make you alerted of such activities and behaviors. Again, from an investigation perspective, the events and incidents are enriched with MITRE context to help provide much more richer visibility and better understanding of the malicious activity techniques and tactics and how it made its way through within the environment. Additionally, from an investigation perspective, we have graphical representations of the incident. We'll be having a look into that during the demo session so that we can have an understanding of what are the differences between the graphical representations and what information are reported back or displayed for us and how we can make use of them. Moving on to the EDR hunting capabilities, one of the real power of EDR is to conduct threat hunting across the environment to look for anomalies or maybe for incidents of compromise and make sure that if we find any of these IOCs, we need to take the actions instantly and remediate if any suspected or malicious activity has been conducted so that we can achieve a clean remediation on any endpoint. So the real endpoint search across disk or recorded data can be conducted across various types of attributes, including file hashes, register keys, processes, files, and even more than that. We conduct this activity recorder search directly to grab information from the activity recorder data store that is on the endpoint. And from an evidence of compromise search, we're conducting on the disk itself. So we're going through with the disk scanning methodology to get any conviction of the IOC. Remediation actions that are available in Endpoint Security Complete. The most important ones or the major ones would be the most straightforward whenever any breach has happened or malicious activity has occurred and we have confirmed that this is a true suspected breach. Isolating endpoints and placing them in a quarantine zone and preventing them from communicating with any of the surrounding endpoint machines or even to reach out to the web. We're limiting the opportunity or the ability to spread or laterally move in the environment. And we're sustaining and putting limits to the breach until the point we have remediated and made sure that everything is fine again, then we can rejoin the endpoint. Quarantining files or deleting them as well whenever we have conducted an evidence of compromise, we have got, let's say, a conviction or status of a file that has been found or an IOC, we can initiate a delete of the file, get and download files for further analysis. So this is an important feature where we can get or grab samples of files. If a malware is still residing on an endpoint, we can grab a sample of this file and export it into a zip file format so that we can take it and maybe conduct further testing on it in a separate environment or a safe environment. Others, such as allow deny files, collect file process data, and collect full recorded data dumps, block behavior. This is something we're going to talk about more in details in the upcoming slide. And the option for live shell to endpoint and so forth as well. So one of the important proactive measures that we can take from Symantec EDR is to prevent any future malicious activity that has already been identified by EDR. And this is done by utilizing adaptive protection, which we covered earlier. You can see an example for converting incidents into prevention rules. And on the left side, we see the detailed incident summary for the malicious attack. Where did it initially start from? How it executed, and what was the behavior that was triggered or observed. This type of execution can then be prevented by applying the block action on the relevant application behavior and adaptive protection. So it's achieved seamlessly with a single click, and the outcome is that we have reduced the attack surface and prevented any future misuse of the detected application behavior. Ability to connect directly to the endpoint using the live shell. This is achievable for cloud enrolled endpoints. We can initiate the live shell and work as if we're already on the machine, where we can look into maybe further investigate the machine to look for IOCs, to look for different artifacts or metrics related to suspicious or malicious activity, take additional actions that are far more beyond what is covered, let's say, and are specific and dedicated for Windows operating systems. So all of this is achievable and can be conducted. EDR integration, so we can definitely export data for external logging to get more visibility and to enrich other NEAM or syslog or different types of data gathering servers. We have native QRadar, and Splunk integrations, easily configured and easily integrated. And also additional point as well, which is the Threat Intel API. So you have the option to query the Symantec Global Intelligence Network. If you have any, let's say, IOC that you're trying to look for more details about this IOC as to what the Global Intelligence Network holds. So you can configure this API communication to submit queries to the Symantec Gen and instantly get responses regarding this file or artifact or IOC. So let's jump on to the EDR demo, and I'll go back to my cloud console. So what I did originally is we have a couple of not so much malicious, but some of the Excel sheets that depicts unusual behaviors and does a really comprehensive callings on different types of operating system tools, using different operating system tools and different communication metrics as well. So when we open the Excel sheet, we just enable the macros. It will run the script in the background and it will start the execution. We'll get across detection. This is from the SEP prevent that we talked about. So it's an event that is triggered by the auto protect module or function. We have the file name, we have the risk identifier. From an endpoint protection perspective, this is what we're limited to. So this is all what we can see. We can identify the identifier or the common name of the malicious attack. We can see the location and the file name. Other information regarding the reputation, whether it's been seen by the community or not. What scan type prevented this or triggered this, and that's about it. However, if we go to the Incidents and Alerts tab, and we look into the graphical representation, we'll cover the overall summary and the different attack detections. But before doing so, here we can see a graphical representation of all the artifacts that has been or that has taken place during the malicious activity. And it's not limited to one single activity. I've conducted multiple ones from the same endpoint machine. So we would see and come across different types of executables and different types of executions within the same incident that we have. But mainly, the main thing here to learn about is that all of these artifacts are we can interact with them. We have a full visibility, like a quick overview of what is playing part in the malicious activity and what is important, or what even outbound communications are happening, the different endpoints that are breached or are part of this breach, and what are the main different calls that are happening from the endpoint. So if we look at the excel.exe, just grab a little bit, we can start building up, let's say, our own graph that demonstrates a little bit more about how this Excel was interacting and what was it interacting with. It's a little bit hard because I've already, like I mentioned, I've ran multiple malicious files, and we have all this complicated illustrations, but you get my point. It's more of getting the feel of what is really in play in terms of the attack that has happened. So once we have, let's say, a brief or a solid overview of these types of on these types of artifacts, we can look into more details on the fact that, or into more details into what has been happening and what has been going on behind the scenes with those files or attributes, artifacts. On top of this, we have the process lineage, which shows the execution history from start till the termination process. We can simply see the start of the execution where the Windows login or the user logged into his machine. Just clicking on any of these is going to yield the investigate summary, where we have the application name, which device was it, the hash of the file, disposition, the username. Moving on or moving forward with the process lineage, we can start looking into a more informative layout. So we know, first of all, that test user has logged in, user initialization has executed, and there has been a call on explorer.exe. This is a normal, legitimate call. However, we see three different Word documents that has been called and opened, and each one has different sets of child process calls as well. So if we start by looking at the first one, for example, first one, which is the salaries.xls, this is the exact same Excel sheet that we used for the adaptive protection test. So we know, first of all, that there is an Excel sheet named salaries.xls, and we know the path of the file or the path of the Excel sheet, and we have the hash of the file. We already have lots of information to conduct further investigation and threat hunting and better understand what this file was trying to do, and is it a real harmful file or not. If we look at the action call that was committed, it was a CMD directory listing for the C partition which was exhibited upon clicking on the macro button. So not something of a real concern here. However, if we go to the second Excel file named upcoming events, February 2019, XLSM, we have it's coming from the same location. We have its hash value. It was executed by test user. We see the MITRE attack mapping here from the application. And what was the Excel trying to do? First of all, if we look at the certutle, we can see it was trying to conduct a certutle decode and trying to execute a file that it already created, but we don't have this information yet because it's part of the further investigation and analysis that we'll check upon. Process activity launched by test user, have the time frames and the MITRE attack framework mapping. And for the executable, we see that it already as well placed itself in the program data file and tried to launch a command line to execute and run this executable, which we have seen that the endpoint protection stack already prevented it and disrupted the execution. So moving from here, what actions can be taken or what we can achieve more to remediate or to take the actions after the investigation, since we already have come to the point where we have an understanding of what has been happening or what are the artifacts that are playing role in this malicious activity. Quarantining the device is simply straightforward. One of the approaches that we take to contain breaches or the spread of breaches and lateral movement. We've introduced two new options to either block all network access except the Cloud Console, Live Update, and Symantec Security, or allow network access by the host groups, along with all the Cloud Console and Live Update Symantec Security response. So you have the option to choose between them. For just demonstration purposes, we'll block everything except the Cloud Console and all the other communications which are required for further actions and remediations. And since we already have one important information, which is the exact file name and the exact location of the file that was executed and that resulted in this trigger detection, we can take this file name and we can simply go to the Investigate tab. We can look for an evidence of compromise. So conduct an endpoint search, select the evidence of compromise. We're searching for a malicious Excel. We select which devices we're trying to conduct this search across. In our case, it's client 1. And apply the field for file path. We do have different fields to look for evidence of compromise. It could be a file hash, a file path, a directory path, or even a process MD5 or process SHA-256. So in our case, it would be a file path, which equals the value of the whatever and the name of the Excel sheet. I've already initiated this, and I have the result here just for time's sake to not take so much time. So if we go to the event itself, we can see it already returned a search status of completed and found in the endpoint. From here, moving forward, we can go check the file details. Expand this. We can look at the risk of the file, how many devices this file has been seen on. Since this was one important, let's say, artifact that we have come across, it could have been delivered through maybe an email, a spear phishing type of attack that has been distributed to multiple clients or end users. What we really need to look for as well when we have such artifacts is to conduct the IOC or evidence of compromise search efficiently to look for wherever this file might be residing, or it can be hiding in plain sight, or even under the radar on any of the endpoints that are distributed across the environment. So back to the details of the file, we can just have a quick summary of the file. We have, again, the folder location, and once we have a clear, or we have got the search status reported back, we can further conduct further actions such as submitting to the sandbox, or getting the file for maybe further analysis. We get a sample of the file, place it in a zip file, and put it in a safe environment, and go do some testing on it, further testing to understand its behaviors. I've already submitted the file to sandboxing. Just to go through the sandboxing results, we can see the number of events that has been already populated as part of the processes and the different process launch activities or system activities that has taken place during the activity, or the malicious attack, or the malicious execution of the Excel file. We can refine those into a more readable format, so we can look into specific, let's say, process activities. We can see what Excel has been trying to do. We can just expand this a little bit. No, it's not working. Okay. So we can see here, if we go a little bit down, we can see Excel launching the generic executable file that was created. Some run DLL launching, certutor execution or launching. So it's a really comprehensive event visibility into all the different behaviors that this file has depicted, which can help us further as well identify maybe really crucial aspects of the attack that might need further remediation or actions to be taken. So we have the file activity as well. We can look into the different file related activities that happened, and what files did it call for, and it opened and created, or and so on. So we've got all the information. We can simply just go ahead and okay, we can go back to the incident page just to look at the other actions, and shows within the incident response capabilities. We've done everything related to the investigation. We'll go back to the Excel sheet or Excel, get the information. I'm trying to just it's taking me backward again. It's okay, we'll just disregard this. So what other actions as well can be taken is we can initiate a full dump or a process dump. And recently we have introduced a new option within the full dumps to collect the dumps or activity recorder for specified time range. So we can select either a quick filter, out of which we have various different options, or we can specify an absolute full dump. This will absolutely help us in refining and getting a more valuable event stream, and we don't have to need to worry more about unnecessary or noise events. Process dump is applicable as well, and the block behavior capability, which we talked about. So this is where we shift an application behavior that is depicted directly into the adaptive protection policy. We select the policy, it goes directly to the policy, and we can block the relevant application behavior. It should map it by itself. Not sure if, I think because I've already denied it manually, so it's not taking the action, but this is how it's achieved. And finally, as part of the investigation and the actions that can be taken, the live shell connection or communication, which is a really useful feature and function to make use of. So we can instantly start a live shell. We just supply the username. Hope that I'm typing everything correctly. Just connect. And until it just comes up, we'll come to it back at a later stage. And one final point in regards to the incident rules. So as we've discussed during the presentation slide, we have a subset of incident rules that are all listed for creating the incidents in your environment. What behaviors should trigger the incident? But that doesn't mean that the behavior is not monitored. The behavior is still detected by the sonar engine or the behavior monitoring engine. However, only once enabled, you have an incident created for such behavior so that you are alerted and you can take actions upon it. We have the event counts. So let's say Mimikat attempted to dump credentials. There is a 270 attempt conducted on this behavior. This is something maybe crucial that we need to look into. We can enable the state and look further into the other incident rules. And most importantly, the custom incident rule that can be implemented. It's very comprehensive in terms of what we can build. So it's more of a condition based with operators. We can create custom filters with a huge bunch of attributes and different types of fields that we can maybe make use of to build up a specific application behavior that we don't want or we want to monitor in our environment and maybe have be alerted in an incident about it. And here it goes. We're just logged into the machine. We can start listing the directories. We can initiate different types of commands and look into the endpoint itself, maybe take the actions if actions that cannot be taken by EDR, maybe that can only be initiated from the Windows machine itself. So we have this option as well. I think that's it from my side for the EDR demo. Let me just go back to the presentation slide and see what we still have to cover. Maybe we come back to the demo portal to go through maybe some other features and components in endpoint security. So moving forward, we've talked about endpoint detection and response, and we've talked about the capabilities and all the benefits that it gives and how it's different from competition and what is the key differentiator in comparison to competition. However, if we want to expand a little further beyond EDR, and here we're trying to see an illustrative diagram for XDR in action. We want to specify or we want to identify threats more efficiently across multiple cross points. And the aim is to correlate user activities that are happening outside the viewpoint of endpoint alone. And finally, present a full picture of the threat. The approach is achieved by integrating the Endpoint Security Complete with CloudSoc. And as a use case, assuming that an attacker already has breached an endpoint and maybe made his way and got access to the user's SaaS-based services, from an endpoint point of view, an incident will be created for the breach. We will have the visibility into the endpoint events, which mainly might consist of process launch activities or other activities like registry key changes or even malicious application behaviors. However, all the activities that are conducted on the cloud services are far out of reach of the endpoint point of view. So whenever the attacker is interacting with those or interacting with those cloud services, all the activities that occur on these cloud services are being recorded by CloudSock. So, for example, if the attacker interacted with or downloaded a file from Office 365, this activity is recorded by the DLP component. And since we already have an integration between Endpoint Security Complete and CloudSock, the embedded XDR enriches the incident that was created with all the relevant CloudSock events and incidents. Next subject, which is the Active Directory, threat defense for Active Directory. By design, the Active Directory is open to any domain connected user, meaning all the identities and resources on the corporate network are visibly exposed. And once an attacker puts a foothold on a domain PC or machine, the attacker can perform reconnaissance activities. He will try to look for valuable resources across the organization to make use of or try to breach or conduct credential theft or privilege escalation against them. So AD is something that is overlooked by many, but it's really extremely important because this is one of the last line of defense measures, especially when it comes to a breach, such as when an attacker has got some kind of control over an endpoint and is looking to escalate the privilege and move laterally in the environment. Threat defense for Active Directory provides real-time forensics reporting. It captures reconnaissance and credential theft and lateral movement. This is what it's designed and scoped to do. It will apply obfuscation on endpoints using deception policies to deceive the attacker and provide him with fake resources. Once there is an interaction on these fake resources, the Active Directory is triggers an event or an incident and takes the necessary action to disrupt and terminate the execution. And all of this approach is endpoint based and built into the same Symantec Endpoint Security Agent, and no changes to the Active Directory is done at all. And so eventually, in a nutshell, the main purpose of TDAD is to block the first lateral movement attempt right at the point of a breach, and also prevent attackers' ability to steal the domain admins. Part of the Active Directory defense is the breach assessment tool, which is one of the most useful tools that can be instantly downloaded and executed or run on any domain joined machine with any regular domain user. It will simulate a breach, look for dark corners and vulnerabilities, and conduct tests against the Active Directory to look for different anomalies in the Active Directory. When the tests are completed, the breach assessment tool will report back all the detected dark corners and all the vulnerabilities within the Active Directory environment, and it will provide clear recommendations and remediation actions to be conducted or done by the administrator. Moving on to mobile threat defense, which is mainly the mobile factors are really driving risk for enterprises. The employees are using their mobile devices for various business-related activities, such as email clients and access to company online services. And any compromise on a mobile device might lead to data exfiltration. We need to keep all these business-related information secure, and Symantec Endpoint Protection Mobile offers such type of proactive mobile threat defense approach. It detects and prevents mobile threats and attacks across all the operating system, modern operating systems such as Android and iOS. It mainly protects and alert devices from various types of activities such as suspicious network connections, also malicious or unwanted applications, also malicious and phishing URLs and domains. It will also conduct OS vulnerability checks and risky configurations, all of which can be reported back in a summarized way so that we can have an understanding of all the gaps and the things that needs to be acted upon, whether it is a breach or suspected vulnerability or any risky configuration that needs to be rectified and fixed. The solution consists of two major UI components. We have the SEP mobile app, which can be downloaded from the iOS or the Android store, and the Endpoint Protection Mobile Management Console. The Endpoint Protection Management Console has integration capabilities with MDM solutions and EMM so that we can discover devices, enroll them easier, and maybe have more control over the protection capabilities over them as well. Network integrity, one really interesting feature, which is mainly dedicated or specific to help in protecting users that are roaming and connecting from outside the network or connecting from public Wi-Fi networks or wherever they are. These users are vulnerable to man-in-the-middle attacks, where an attacker might be spoofing their communication, maybe stealing their information, and even could be infecting their machines with malware. So we need a solution to cover this gap, to secure those roaming user endpoints wherever they are. So we have the network integrity, which provides this type of protection. It uses the reputation to assess the risk of the network. And whenever these types of suspicious networks are detected, the network integrity protects the user devices by either disconnecting them from the network or establishing a smart VPN tunnel for secured and encrypted communication. This is ultimately a secure, this is an ultimate approach to provide or achieve a secure and safe web surfing experience. Users are also securely accessing the business-related applications. Hence, we're keeping all the business-related information secure and safe. This feature is supported across mobile devices for iOS and Android, and in addition to the Windows 10 operating systems. Deployment models. The Endpoint Security Complete offering does provide any of the three deployment models. So whatever the customer's requirement is, whether to retain a full on-prem infrastructure, we do have this option. If they're looking to move fully to the cloud, also that's a feasible option. And a hybrid in-between model is applicable as well. One important point here to note out for the hybrid managed environments, because it has been causing confusion a lot recently with so many different customers, assuming that they are half and half in between the on-prem and the cloud. However, it's more of a fact that you are retaining your on-prem infrastructure. Everything is still retained on-prem. However, you're adding some capabilities from the cloud. So when you integrate the SAP Manager or bridge it with the cloud console, the ICDM console, you have the ability to apply some additional protection measures, such as the adaptive protection feature and the application control. These are two examples of what can be ingested into the SAP Manager upon integrating it or bridging it with the cloud. And the ultimate use case of a hybrid scenario is for those whom are in between cloud and hybrid or on-prem. Uh, we have real benefit in terms of consolidating the event visibility across both, so that all the events that are occurring on-prem and the events that are occurring for the cloud enrolled endpoints, all of these are consolidated into a single console with central visibility, and some of the um, main actions to be taken across both the deployment models is achievable through a hybrid managed solution from a single console as well. So this really comes as a preference and as per the requirements and whatever the customers are looking for. As for the migration to the cloud, it's fairly simple. We utilize the same semantic agent across all the three deployment models, which makes the transitioning easy and eventually overcomes the complexity of redeployment. So migrating from on-prem to the cloud can be seamlessly achieved and without the need to reinstall the endpoint packages. Recently, we have introduced a new option to redirect the client communication from on-prem to the cloud using the switch to cloud managed component upon the hybrid integration. So once we have set manager integrated into the cloud or bridged to the cloud, the devices are synced up to the cloud. All the device hierarchy that are on-prem will be visible on the cloud, and we can simply go select the device group that we're looking to migrate or enroll directly to the cloud, fully to the cloud, and with a single action to switch, single action button to switch to cloud management. It happens seamlessly. The redirection all happens in the background, and once the endpoint is enrolled and redirected to the cloud, an automatic auto upgrade is conducted as well. And you have the full control as to when to conduct this auto upgrade and to configure the timestamps or time slots for the best feasible timing for the auto upgrades. The integration with Symantec and third-party solutions, we have direct integrations between Endpoint Security Complete and web and email products such as proxy and web security services. This is one of the most useful cases when it comes to customers that want full protection across the endpoint and the network level for users that are maybe connecting from different regions of the world. They are roaming around and they need not only the endpoint protection, but they need to have the visibility and the content analysis or content filtering and the protection of all the network related activities conducted by the user itself. The WSS and proxy are achieved simply using the same semantic agent, no requirement for additional implementation of agents. It's a seamless approach, easy to employ or deploy and configure. Additionally, from an information protection perspective, we have the data loss prevention and CloudSock, CASP, both of which we've talked about the XDR and the enumeration of XDR capabilities by integrating the Endpoint Security Complete with CASP, which is a high value of enriched context and brings much more event visibility in the environment and provides more detection metrics in terms of what's happening beyond the viewpoint of the endpoint itself. And we have integration with endpoint management, party management solutions, and of course the third-party integrations with ticketing systems or even orchestration and automation, such as SOAR platforms. We have integration with IBM QRadar, SIEM servers or syslog servers for external data sharing, API integrations as well for automated actions and response actions to be taken. So all of these are capabilities within the integration capabilities of Endpoint Security Complete and fairly achievable. Finally, the last slide is something that is on the roadmap, which is a three-phased approach to a single agent. What we are trying to do is eliminate the complexity and overhead of multiple agent deployment and reduce the resource consumption. We are at the current state where SEP and selective network steering components such as WSS and CASP has already been integrated within the single agent approach. And we have customers who are already utilizing this type of WSS traffic redirection capability. All of this is seamlessly achieved using the SES agent by itself alone. And the LP is currently in progress, and hopefully in the near future, it will be part of this single agent approach. Now, I know we are far behind, we still have so much time. The plan was to have a TDAP demo, but unfortunately, which I had, but let me try before, because I had an issue with launching up my lab today morning and I couldn't just bring it up again. I was planning to go through a really interesting demo for threat defense for Active Directory for approximately 15 minutes. Yeah, so it's still not running. I'll try to refresh it and run it again. Hopefully it comes up in the upcoming 5 or 10 minutes. Until then, maybe Ashraf, we can start taking some questions. Maybe we can have more of a discussion with the attendees, have it more of an open discussion. I think this will be as well useful.
Sure. So I'll start with a couple of questions that have been asked on the chat and the Q&A. One of them is about the adaptive protection, and does it require the cloud and works with the cloud only, or it can be usable for the on-premises environment?
Yes, good question. And that's what I was trying to cover up in the different deployment models. So it is applicable for the cloud enrollment along with the hybrid enrollment. So if we have an on-prem SAP manager, to get and make use of such a capability, we can simply bridge the Symantec Endpoint Protection Manager with the ICDM console. It's a fairly simple and straightforward approach. We just copy a token from the ICDM console, paste it into the SAP Manager, and the integration is seamless and happens in the background instantly. Once we have the bridge completed, we can then apply the adaptive protection policy from the cloud, and we can have visibility onto the application behavior monitoring on-prem. So yeah.
Okay. Another question here I see is about the SEP mobile licensing. Is it included as separate agents when it comes to sizing the endpoint security complete, or it's so in other words, what would be the sizing criteria if there are mobile devices included in the sizing?
Oh, sure. So it basically accounts for a one seat license count. So wherever you're using it, the approach for endpoint security complete is based on the seat counts, and the coverage is again across all types of devices and operating systems. So if you're placing the endpoint security agent on any of the devices, whether it is a mobile or a Windows or a Linux machine, desktop, cloud workload, or even a server, we're taking into consideration that is this is one of the endpoints or devices that we're implementing all the security technologies and putting all of them within the endpoint agent. So it actually accounts for one license seat count from the overall seat counts that has been acquired by the customer.
Okay. Another question is about the incorporation of encryption of data at the endpoint level. I think this is more into the disk encryption.
Yeah, it's a separate
Solution.
product. We do have a solution specifically for encryption, one comprehensive and really good value product that can achieve encryption at the disk level, at the endpoint level, and conduct all the encryption requirements as well.
Okay. So I think these are the questions that I can see. I, I I think I have one question from my side, mainly about the EDR capabilities. Now, currently, you would require a hardware on premise or a virtual machine on premise, or it can be all worked out from the cloud as a single platform for it.
Yeah, a good question. So for the EDR, I believe we came across one of the slides that shows the different models that can be adopted by the customer. We have both the on-premise EDR approach, deployment model, and the fully cloud one. The on-premise have two different options. We can either adopt a physical appliance. This physical appliance is deployed and bootstrapped on the on-prem, or we can grab an OVA file once we acquire the license and deploy it on a VMware ESXi environment. So this is from the virtual part, a virtual perspective. For the cloud, it's already implemented within the back end of the cloud console or the cloud architecture. It's simply a method of applying the policy. So we go to the policies tab. If you can see here, we can go to the default detection and response policy, turn on the activity recorder and apply it to the devices and device groups, which will enable the feature and all the components and the activity recorder capability. So yeah.
Okay, and one last question would be mainly is, sorry, I went out of, I'll just check one of other questions. Okay, I can answer this. So, can partners have the licensed solution to try on lab environments? Yes, indeed. You can just request an NFR for your environment, and it will definitely give you 1 year of license with the solutions. So you can contact me or your SE in your country, and definitely we will help in providing the licenses for it. Okay, so our lab for the threat detection for Active Directory is down, right, Ahmed?
Now I have access to a lab, but I haven't prepared anything on this because I
If
just
we can,
generated it, and it has no
okay,
configurations
if we
yet,
can
but
have
I
a
can
walkthrough.
demonstrate. Yeah,
Yeah,
I can just have
walkthrough
a
only.
walkthrough for
Mm,
sure. So let me just go through it.
perfect.
Okay. You can see my screen, right?
Yes.
Okay. So here we have two different machines, one of which has the endpoint protection agent installed, and we have a machine which does not have the endpoint protection installed, and it does not have the web defense for Active Directory capability. Just reorganizing the screens. Console. Okay. So the AMI Windows 7 machine is protected. Windows 7 machine Charlie is not protected. What I'll be able to demonstrate is just one of the approaches that Active Directory applies, which is called deobfuscation. We're trying to implement fake resources on the endpoint based on a policy that we configured. And in this way, we're trying to limit the possibility of attackers whenever they have any foothold on the endpoint to interact with real legitimate resources or maybe domain admins or domain computers, which really closes the gaps and limits the possibilities of any further lateral movement or escalation. So this is a machine, again, that does not have Active Directory. A simple command prompt to look for the net group domain computers, for instance. I think the domain should be we'll have a fairly readable or countable list. As you can see, these are all legitimate resources implemented in the Active Directory database. Each one has a record in the Active Directory database. And on top of this, if we also look for domain admins, we can see that the count is fairly 3, 6, 8 legitimate domain administrators within my Active Directory organizations. And bear in mind that these types of queries are legitimate queries. These does not require any escalation, that does not require any privilege. Any user on any domain connected machine can conduct and look for such resources. These are not fairly complicated. It's very simple and straightforward. Can barely make use of something of them, but from a more sophisticated type of attack, which maybe I can demonstrate, I'll just have to check if the module is installed or not. On the other hand, we have the one which has Active Directory protection implemented. And if I run the same commands, I should get a fairly larger results, which is obfuscation in play. I think my configuration is a multiplier of 10, so it'll look for the count or the number of the real resources multiplied by 10 and implement all of these fake resources. These fake resources are not configured or implemented in the Active Directory. The Active Directory domain controller is not touched. These are all memory manipulations that are solely based on the endpoint itself, and it's just implemented within the memory. So you can see the huge list of resources. If I ping or interact with any of these resources, let's say I'll just pick up SQL64. So if I go and ping SQL64, fine. So we'll check it up in the threat defense management console. I'm not sure if this is how it should pass through. But any interaction with these fake resources will trigger an incident in the Active Directory console, and then we have a summary of what has actually happened. Now, from a domain admin's perspective as well, if we run the same command group, well, for some reason,
Okay, and as you go, we're getting a few questions about the fake accounts. So, one first question is the list of fake domain accounts customizable?
yes, absolutely. So we can configure the deception policy and the multiplier of the deception policy within the threat defense for Active Directory console. This is done during the part of the integration when we're integrating with the SEP manager and applying the deception policy. So just if we look at, I believe
we can configure the names to be slightly similar that what we actually have or completely different from what we actually have.
yeah.
Mm.
Actually, the module itself, the deception module itself, already makes use of what's already existent, and it using the artificial intelligence and automation capability it has, it automatically generates based on what you already have. And it's something that is delivered by default through the threat defense for Active Directory console as part of the
Okay.
deception approach. So absolutely, yes, this is by default achieved and no need to worry about it.
Okay, thank you. And the next question is, can you just elaborate more on the memory manipulation deployment and how it would be worked out?
Actually, this might be more of a back-end explanation or clarification, because it's real deep into how it inserts all the different configurations or changes and all these deceptions in the memory, which I'm not sure if I can just provide it in a simple context. It's more of a back-end thing that is related to how the engine works and how we implement it. But to put it in a simple context, so we're not doing any creating files. We're not doing any module modification, or we're not making any changes in the environment itself. What's happening is the Active Directory module, whenever integrated with the endpoint protection agent itself, a policy is applied from the threat defense management console. This policy will include all the different metrics and the different configurations that needs to be configured. And once it's enabled on the endpoint, it will take the role of placing the different memory configurations at the memory level, so that whenever the user is running the endpoint, it's always retained there in terms of how it works, and to keep a low profile whenever there is any attempt of breach or lateral movement or whatever malicious or suspicious activity might be there. So the goal is to achieve a low profile approach for such types of activities, and keep minimal footprint or impact on the machine itself. So we don't want to keep real artifacts or information on the endpoint that any attacker can make use of. That's, I think, the most simplest way that I can provide the explanation for that.
Okay, thank you so much, Ahmad. I think we're fine with the questions. Technical recordings definitely will be sent out once they are ready to all the attendees. And please, you can always reach out to us and even to your local SE team for any further clarification you want on top of that.
Yeah, but Ashraf, before you end, because I just wanted to go through one of the incidents created by threat defense of Active Directory, just to
Okay.
demonstrate how it applies the forensics and what information it shows us. So one of the most commonly used tools for stealing passwords, it's a well-known application called Mimikatz, and we have a technique which is called passing the hash. We capture the NTLM binaries of a domain admin. This is done after a reconnaissance activity, which I was hoping that I was able to demonstrate it today, but unfortunately we were not able. So it captures such types of activities, and it demonstrate or report them in a chronological order and in a summarized way to give you the full picture into what has happened in the activity from start to the end. We can see the source attack, where did it come from, which machine, which user, what was the suspicious process in action, the different artifacts within this, such as deception and malware and command line shell. What are the grab memory credentials? So here you see the memory credentials for the help desk account was masked, and this is what was used to pass the hash to get a privilege escalation. And then we come to the timestamp of the NTLM authentication, and the user eventually got access to the DC. Or tried to reach the DC, sorry. This is part of the prevention. So on the other hand, the endpoint which does not have the threat defense or Active Directory, we would have been able to reach out to the DC and list or take actions on the domain controller itself. All of this is reported in a comprehensive summary and clear context, where you can have an understanding of what has happened. It will create as well a forensics report that we can look into a more detailed layout of the process IDs and the processes, the calls, procedures. At some instances, it captures screenshots. I believe it already did in this case. So we have a screenshot when this has happened, but it's not relevant, I think. This has been a failed test, I think. And other evidence of execution, artifacts, and the file systems related to the activity that we can look into. So it's a fairly complicated and comprehensive a comprehensive approach to detect and prevent activities or conducts and misuse of Active Directory or any activity against Active Directory itself. And just wanted to highlight that as in high level. So that's it from my side.
Thank you, Ahmed. One question has come up to when you were talking about it, about the memory manipulation, and if we can use it on servers and ATMs. Will there be any issue which we have to consider before applying it?
Sorry, I didn't get you. Can you come back again?
The question is stated that memory manipulation can be used on servers and ATMs. And the question is there any issue which we have to consider before applying it? Not sure if it's applicable for ATMs, probably for servers more. Correct me if I'm wrong, because for ATMs it's for legacy platforms.
For sure, not only legacy, it depends on the environment itself and the actual ATM configuration and how they're configured and whether they are domain joined or just left standalone on a workspace or whatever. Not sure, I don't have much information about that, but what I can say is the word memory manipulation is not something that causes any issues or implications or impact the endpoint in any way, shape, or form. And this is a fairly low profile approach just to implement deception so that we can deceive attackers and limit the possibility of any interaction with fake resources. It will not conduct changes at the operating system level, neither at the domain level or Active Directory level. No changes are done at all, no footprints in terms of resource utilization or whatever. And it's a low profile approach that have no impacts to any endpoint. For the ITMs, it's a different story. It depends on what operating system they are running, whether they have direct communication with the Active Directory or not, if it's something that is really in need or it's useful to implement on. So this needs to be further checked and analyzed or discussed further.
One point to highlight as well, especially for the ATMs and IoT devices, which mainly they are running legacy platforms. The best option is to promote the critical system protection because they have also the feature for the privilege de-escalation modules that will harden that operating system from the base, not only just doing some memory manipulation or any other
That's absolutely true.
for it.
Yeah, absolutely true.
Okay, great. Thanks everyone for joining our session today. It was really fruitful, Ahmed, especially the demo part. I think we saw some stuff on action, and please, as I mentioned, you can always contact us and through the local team that you have on site, and we'll be more than happy to assist in any opportunity you have. And looking forward to get your feedback once the session ends. So thank you so much, everyone, and to the next series. Hopefully, we have next week CA part. Mainly on NetOps. So if you are interested in attending the calls, please register through the same invitation that you have received. Thanks everyone and see you soon. Thanks, Ahmed.
Thank you, Ashraf, and thank you everyone. Have a good evening and see you later.
See you.
Bye.